Hello, and welcome everyone to this session, Understanding Single Pair Ethernet. It's our privilege to bring this another session with another thought leader of the industry on a technology that's evolving. So glad to have you here. We have people join from various cities, various industries, various companies, and once this goes live or and gets uploaded to other mediums, we'll have people watch over YouTube and other channels from different mediums. So welcome again to everyone. My name is Anant Taparia. I take care of marketing here at Utthunga, which means me and my team have the responsibility to take to the world the message around our product engineering capabilities for the industrial world. And today I'm very privileged and honored to have Matthias Fritsche from Harting as part of our guest to be speaking on this topic, single pair Ethernet. Before I have Matthias introduce, just wanted to let you know that Matthias is the senior expert Ethernet connectivity at Harting and also the leader of technology working group at the Single Pair Ethernet group. So I request Matthias now if you could briefly introduce yourself to the audience, probably getting the first chance to interact with you.
Yes, thanks for the very warm welcome, Anand. And thanks also for the invitation to this call today. As you already mentioned, I'm working for Harting, and here I work in the past as product manager for Ethernet connectivity, and now I work for Harting in several standardization organizations, mostly also at IEEE and TIA, also ISO, IEC for the cabling and connector standards. And yes, I'm also the technical chair of our technical working group at the Single Pair Industrial Partner Network. And here with more than 50 companies worldwide, we create together all this technical content, application notes, white papers, and so on. Yeah,
Great.
Thanks.
Yeah, thanks, Matthias, for the quick introduction. Before we get started, we have limited time. It's going to be a packed session. Lots that I want to, ask Matthias and get his views on for all the people tuned in today. Just a quick housekeeping point: the session is 30 minutes. We'll use the last 5 minutes for Q&A from the people attending via LinkedIn. So request you to please post your questions via the chat panel in the LinkedIn window that you have. Great. So let's get started, Matthias, and really let's dive into the questions. As I said, we have a lot of those. So the first question, of course, let's start with the obvious question. I think that we probably set the context for the rest of the session. What exactly is SPE? What is SPE really?
Yeah, very simply stated, single pair Ethernet is a new physical layer, and this physical layer is using just one single pair of twisted wires. Yeah, it's similar like we use today optical cables or cables with 2 or 4 pairs, single pair Ethernet just using one. All the upper layer functionalities are more or less identical with standard Ethernet, yeah. Yeah, and also some words, also what we want to share with you here about the single pair industrial partner network. So for this new technology of Ethernet communication, we need a lot of things we have to bring together into the market. And this is a job most too big for just one company. And that's why we founded the single pair industrial partner network. And you see on the card there are more than 50 companies all over the world. And we work together in this group here. One big topic of the single pair Ethernet partner network is the so-called SPE ecosystem. And this is a picture we created to make it visible what it's behind single pair Ethernet. So in the center, you see the technology itself, mostly developed by the chip manufacturers. And then around, we have the huge landscape of standards. And these standards, of course, are needed for any kind of communication so that you can produce mating and working compatible interoperable products. So here we have all the standards. And at the next level, you see at the ecosystem, the components you need. You use this technology inside your devices, inside your installations. And this starts, of course, with the semiconductors here, especially the PHY chips and switching chipsets, the magnetics with all this filter and transformer components, and of course also the connectivity, a lot of accessories, and of course also testing and tooling. And if this components are existing. This is more or less the step we see today. We can jump into the real applications and we can create the devices like switches, of course, at first, switches and media converters, and then also other devices you need to use this technology in a wide range of applications. So PLC controllers, frequency transformers, a wide range of sensors and actuators. And in the last level of this ecosystem, you see some collections of industrial use cases. Just to mention some: automation, of course, machinery, robotics, but also smart city and smart grid applications, and then also mobile applications, rolling stock, mobile working machines in agriculture and building construction. So it's a huge range of possible applications. And yeah, this picture shows a little bit what we are doing, what is to do in the market to bring this infrastructure working.
Yeah. Yeah, great. Thanks, Matthias, for the introduction brief to SPE. Of course, we'll dive into it quite a bit, and of course, also to introduce the industrial partner network. That's also relevant for people to understand. And just to add on what you said, for the techies who are here, and I'm sure a lot of them, the OSI layer, 2 to 7, really nothing changes, yeah? And so there's hardly any additional work in terms of development. If you're used to the standard Ethernet, in terms of application development, there's nothing that changes for you. So that kind of leads to a lot of minimum constraints in terms of perhaps the adoption to SPE. So we'll kind of get into those topics, of course, with Matthias. So Matthias, then I want to dive into the second question, and perhaps must be in the mind of the people as to why is SPE needed, really? I mean, what is the pain point the two-wire Ethernet, the SPE, is intending to solve for the industry?
Yeah, this is a very good question. And I guess at this point, it's also very helpful to remember the initial driver of this new single pair Ethernet protocol family was the global car industry. Yeah, so they need more powerful networks for all these new functions inside the car, self-driving assistance, or in the future, fully automated cars. And the networks they use today, like CAN bus, FlexRay, MOST, Lin and others, are not powerful enough now for this. And they searched in a longer time and found Ethernet is definitely the right fitting technology. But they want to have something adapted for the car. So they have space constraints, weight constraints. And at the end of the day, only a one pair cable infrastructure here was possible. At this time, where the car industry was searching for it, it was already around 2014, 15, so longer time ago. Proda Reach was available from Broadcom as technology in the market, and we are the way over the standardization at IEEE 802.3 group. SPE was born. Yeah. But very quickly also some other industry segments where we are coming from, the industry, identify this technology and jump into this trend to use this new communication standard based on Ethernet also for other applications. And so I remember, for example, in 2016 already, I was member of the 1000 base T1 task force, and I presented a lot of use cases, what I see also, what we see at the ecosystem in mobile working machine, industry, and so on. And others also present here something, potential use cases in airplanes, trucks, and so on. And this was a starting point where we defined the first time a 40-meter channel, so longer than the typical automotive 50-meter channel. And I guess this was a starting point for SPE outside of the car industry. And one point more, if you look to the today industry application, process control, automation, building automation, we have the dominating system, especially in the field level, with all this legacy bus system. So we know Profibus, CAN bus, ASI, DeviceNet, and much more. And at the higher level, today, the dominating system at the automation parameter is this industrial Ethernet protocol. So we just see that Profinet is powerful, EtherCAT and Ethernet IP. But between all these different communication systems, we need a gateway, yeah? And to make an example, if you have a temperature sensor in a machine, for example, today, it's maybe connected with ASI to an I/O box, and when it goes to the next level with Profibus to a PLC system. And just in this simple example, we have 3 different gateways. and all of them must be designed, maintained, and so on. And this is definitely a huge effort for the industry. So if we switch over in this case to SPE, also in the field level, we have always up from the higher level to the field level, the TCP/IP protocol. We can use all the powerful security tools, end-to-end encryption, for example, this powerful tools in the time-sensitive network working toolbox, and so on. And talking all these aspects together in consideration, I guess our statement SPE is a perfect fit infrastructure for IoT, and IIoT infrastructure might be reasonable and true.
Yeah. I think that's a fantastic point you say. I think one of the drivers, the fact that perhaps protocol converters, introducing latency and a whole lot of other complexities that get introduced, but all the way Ethernet from sensor to the cloud, and your tagline rightly reflects it and perhaps really holds the potential for that. So, and you mentioned an interesting point of the origins of SPE in the automotive world, and given where we are today with ADAS systems, the advanced driver assistance systems. I mean, the 1 Mbps needs, of these cameras and the radars and the lidars, they just cannot be met by CAN, or
Exactly, yeah.
Great. Well, let's get on to the next one and kind of really try to contrast it with the existing Ethernet technology, the standard Ethernet. What do you think, Matthias, are the advantages of SPE over standard Ethernet?
Yeah, one of the big advantages, of course, also coming from the car industry is the design of the cable. So we have just one pair. The cable itself can be thinner. We don't need so much material like plastic and copper to produce this cables. That is one aspect coming up from the passive infrastructure, but also inside the devices, you need only a smaller amount of the magnetic components. For example, only one filter setup and only one galvanic isolation. This also gives the possibility for the device designer to make the devices smaller. And I guess also taking this together, the cost reduction is possible for future if this technology is in high volume production. And also here the car industry is helping with this big potential. But as we mentioned before, from my point of view, the main advantage of single pair Ethernet is a barrier-free data communication with this Ethernet system from the sensor actuator level, so from the field level up to the control level, the OT and IT world. And this is definitely could be a big advantage for this. And in this way, for example, a sensor can become a fully fledged network device. So today, the PLC system asks regularly each sensor to send data. If a sensor is a own network device, they can send event-related the data, and this also helps to reduce the amount of data we have to transmit in this way.
Yeah, great. So now that we've sort of got a little foundation and understanding of SPE contrasted also with the standard technology in the market with standard Ethernet. Of course, this has got to get adopted in the market, and the two big stakeholders are the OEMs who are going to build the products on it, and the users who are going to actually use it, in their plants and in their in environments, production environment. So the next question I want to understand, perhaps with the audience from you, Matthias, is what's the maturity of the current SPE product ecosystem, and perhaps more to this point of what challenges do you and the consortium foresee in the adoption by OEMs, to implement SPE into their products?
Yeah, it's also a very good question. And if you remember what we're showing up in the beginning, the component level, all the needed single components like semiconductors and first active devices are available from different vendors today. And we can cover already all speeds from 10 megabit over 1000 meter up to gigabit. And soon also we will see devices and the products for 10 gigabit. And if you want to know more, also I can mention here, you can find the good overview about the first available products at our website. So product.single-pair-ethernet.com. But as you show already the picture, I want to give also some information about the connectivity itself, because this is a key point to have mating interoperable products. And we as a consortium and Harting and TE and all those other connectivity companies promoted and developed together the industrial style, the so-called Tier 1 industrial style connector family. And this connector family is standardized in the IEC 171-6. And it's not only one connector, so the mating interface inside the different connector is identical, but we have different styles we need in the industry, and we can cover in this way everything what it's needed from the industry. You see in the middle the IP20 version, so this is the right product mentioned or usable inside switch cabinet and for light industry applications. And on the right side, you see the different M12 and M8 versions. So M8 and M12 housing styles are common and very often used and approved in the market. And here we have also versions with single pair Ethernet. So you see different screw locking systems, the classical screw, push-pull, and snap-in. And a very special solution is at the left side, the M8 hybrid, also a very small connector. And here we have 2 additional contacts to provide power. So I guess this is a nice solution if you have to provide more power, or if you want to save the effort to integrate this remote powering poodle system. And with this system, you can also create a lot of flexible structure of your network. Not only point-to-point, also line topologies are needed. And one point I want to mention at the end also, connectors are very important, and standardized connectors, of course, too. This standard here is already published as the second extended and improved version since beginning of this year. This also shows up the standard is very robust. And the more important point is also that this standard and the products are inside the standard are listed, specified in several other standards. For example, it's a cabling world for the industrial cabling in your plant, in your factory. We have the published standard of the ISO IEC 11801-3. This describes how to install networks in industrial surroundings. And then if you look the next step inside the field level, inside the machines, we have this fantastic standard, very long time existing IEC 6-1918. Also here is a new version now published beginning of this year, with then adding products and information about single pair Ethernet. And also here the connector is mentioned as the right one. And this gives also all who wants to use single pair Ethernet now a stable fundament to choose the right components, the right connectivity, and start working on developments. If you look a little bit on challenges in the market at the moment, I have to mention also here the chip crisis. At the moment, it's a little bit difficult to get the new chips, but most of them are available. Delivery time is a little bit longer, but I guess this will be solved very soon, and we can say it's the right point to start new developments here.
Yeah, probably a seasonal, momentary thing. Of course, it's been lasting for a while, the supply chain disruption, but perhaps not a long-term concern, I guess, in terms of adoption. Let's change track right now and try to understand it from the end user perspective. The other stakeholder, important stakeholder. What do you think, could be the potential, if at all, resistance in adoption or migration to SP by the end user, the plants, the industries?
Yeah. As we discussed it a little bit, we have more or less, we could let it call it an Ethernet gap at the field level. So at the field level, we still have the dominating of the field buses and so on. And from my point of view, single pair Ethernet will start at the field level and will migrate step by step to higher levels. And this is a little bit different what we see in the past with Ethernet coming at industrial Ethernet that comes from the top town. And I guess with single pair Ethernet, it's really a perfect technology to bring also Ethernet to the field level, because the installation is so much easier. And what we have also keep in mind is how to bring the power also to these devices, because at the field level, the standard is only one cable and one interface.
Okay. Are switches available in the market, Matthias, in terms of that switches supporting PODL capabilities at this point?
So far, not. Some switches are really available. So for different speeds from different vendors, Poodle is not available so far. If we can look a little bit more deeper in Poodle, and we have also a nice white paper and application note on our website. Poodle offers a lot of different voltage levels, and I guess for the industry, we have a discussion at the moment to have an industrial Poodle, just taking care of the 24 voltage levels. Can be, if this discussion is finished, also simplified industrial Poodle systems for the industry will come up. At the moment, this is not existing, but I know there's a development in the background is going on.
And I also understand that, in terms of the specification, multiple bandwidths over multiple distances. So some of those, combinations are also supported. Anything you want to quickly share on that piece for the people?
Yeah, so I guess the concentration at the moment in the industry is mostly on the 1,000 meter channel with the 10 base T1L. Here also remote powering like Poodle is very important. And the first market segment using this technology is the process industry. They call it APL, Advanced Physical Layer. They combine the 10 base T1L standard together with a special for the process industry adapted remote powering. So everything is intrinsically safe to limit the energy. And I guess this is one of the starting points. And what we have also in the market as a discussion to coming from the process industry to a kind of hybrid industry. So the industry where you have in the part of your production a long time running process, and as the other part of your production, the discrete production. The typical example is a brewery. You have this brewery process at one side, and at the end of the day, the end user wants to have the bottles of beer, so that's the discrete packaging. I guess over the way from the process industry to the hybrid industry, it goes to the, I will say, standard automation where we have the discrete part production. And this is one way we see in the market at the moment for single pair Ethernet. Yeah, for the higher level, so the higher speeds, that will be interesting inside the switch cabinet, inside the control layer. At the moment, there are a little bit concerns because of the limited channel links, but IEEE will solve this problem. And still today, we have also applications for higher speeds up to gigabit, maybe also the future 10 gigabit for vision sensors, 3D cameras, and so on will be used. I think about cobots or driverless transportation system in logistics systems. Here also higher speeds are definitely a usable protocol and a usable technology.
Okay. Well, we don't have so much time. I want to ask quite a few questions still. Just quickly, if you want to think there's anything else that people should know before I dive into some other part of the discussion. So any other characteristics that are worth of note? You've spoken a little bit about power over data line Poodle. Anything else that you want to cover quickly?
Yeah, one point I want to point out a little bit again, if you look, for example, to the automation pyramid, so standard Ethernet with all these industrial Ethernet systems like Profinet and so on comes up from the top level down to the field level, ends up at the moment mostly at the PLC systems and controllers. And single pair Ethernet comes directly from the field level. And in this way, if both merge together, we have a Ethernet-based automation system in the market. And this will be a huge challenge for the future. If you look also a little bit to the future roadmap of SPE, as I mentioned, at IEEE, this work is not stopped. So at the moment, we're working also on 100 megabit over 500 meter link length. That will be really also a nice protocol for the industry. Unfortunately, this project will be finished, I guess, beginning of 2024. Gigabit is also needed for longer reach. So many customers ask for 100 meter or more. This will be also technical possible if you look to standard Ethernet. There we have already 10 gigabit. And if you split it down to the 4 pairs, we have 2.5 gigabit in one pair, already over 100 meters. So gigabit over 100 meter also is possible for SPE. And if we have this, I guess for the long-term future, there's a lot for possibilities for many applications, and step by step also in many areas we can use SPE instead of what we have today. So this single pair Ethernet really is a nice technology. It still takes some time to see it in many applications, but there's a great potential behind here for the world. Yeah.
I just want to extend that what you're mentioning and kind of just understand from you, and of course, SPE does talk about it as being the infrastructure for IoT. And a lot of it we've discussed. If you just want to summarize it, as to how does SPE really enable or foster IoT, given the various OT IT layers in the automation pyramid?
Yeah, what we already discussed. Yeah, it's barrier-free communication from, I will say today, from the cloud level back to the field level. This is definitely a vision we need to have, and in this case also single sensors can send data to other services at multiple places. And one point is also, if we compare single pair Ethernet, for example, with wireless, or Ethernet itself, wired Ethernet with wireless applications, also with single pair Ethernet you can produce products you can use worldwide. Compared to wireless applications, you have always to take care what kind of frequency ranges are available in different areas of the world. So 5G is a nice technology, but it's not only one bandwidth and not only one frequency range all over the world. So with wired communication, this is possible. And another big advantage of each kind of wired communication is your own this infrastructure, and you can use it not only for data communication, you can also use it for the powering of the devices. So it's a nice technology here, and it's very secure also regarding to attacks from outside of your factory and so on. That's why with single pair Ethernet, as you see here on the right side, we close this Ethernet gap to the field level, and it's really a way to have a continuous network system with Ethernet.
Yeah, I think the traditional L0 was the one that was perhaps, if at all, the gap to really realize, bring all those millions and millions of devices onto the same network. And with this, traditional field buses would not, there's a lot of constrained gateways and converters and whatnot. So there's really the potential to really bring them all onto the same page, literally. Makes a lot of sense. So you spoke about the origin of SP from the automotive industry. What are I'm sure there are a lot of use cases, but if you want to touch upon a few right now, what are some of the other use cases where you see early adoption already, or you anticipate, adoption pretty aggressively?
So as I mentioned, the process industry has just started and bring this first product to the market last year. So sensor actuator network was we discussed in this session already. We know, and this is not visible in the market, that also in the building automation there are some running development projects, for example, for fire control, alarm systems, and so on. Climate control could be interesting. I guess it will start at the areas where Ethernet is not used today, where we have really the bigger pressure to have more traditional Ethernet communication used in the future. We know also in some autonomous applications, similar like automotive, so self-driving transportation systems, also in agriculture. So there are systems, the agriculture world or the agriculture industry working on it. There is an organization called AEF, Agriculture Electronic Foundation. They have this ISO bus today based on CAN bus, and the next generation high-speed ISO bus is already based on 1000 base T1. So they are early adopters, and yeah, I guess also the engineers will see this technology, and I guess they will use it also for applications we don't have in mind today. It's a very universal communication technology, and we can imagine many things where this technology is used in the future.
Yeah. So, with so much already done as part of the group or the technology of SP, what is coming in the future? So, what is the roadmap? In terms of what can people expect in the next few years, months, and years?
Yeah, as I mentioned a little bit, we will complete the family of protocol standards. So IEEE is working on several extensions, especially to enlarge the reach for higher speed, so 500 meter, 100 megabit, and so on. This will be a topic. I guess also more and more companies will take care for single products supporting single pair Ethernet, and also the number of semiconductors and active devices will grow up very soon. I guess at the moment we see only a very small amount of activities in the market. As usual, R&D work is sometimes behind the visibility in the market. And I guess typically is the way, if you see some products in the market already, there is 90% more development in the background. And I guess next year we will see more and more products also coming using the single pair Ethernet technology.
All right. Well, I'm afraid we've run out of time, as in, we gotta get to questions. I request people to stick on for another 4 to 5 minutes. 5 minutes. We've got a lot of questions. We may not be able to cover all, but that's all what I had, in terms of questions, Matthias. I hope, we were able to at least get a, a pretty compact, understanding of the technology. So let me get to the questions. There are quite a few. I'll try to pick as I get in the order. So the question is, one of the first question here is, how is power injected in SPE?
Yeah, to inject the power to the two wires, you have a special circuit, typically with a common mode choke, to inject this. And also you have a part of the circuit separating data and power in front of the phi chip. So you can do it with capacitive coupling or galvanic coupling. The industry mostly use galvanic coupling. Also for this topic, we have an application note on our website. So if you join to the website, there's a point resources, and here you found a lot of application notes. And one of them is also how to design such a circuit. Yeah.
All right. This question could be a little generic, but I'm sure you would be able to cover it. What is the diameter of this cable? So,
This is a question not so easy to answer. It depends on the cable. If you have a very short link length, you only need a little bit copper, so American wire gauge 22. Typically, such a cable can be between 3 and 4 millimeters overall cable diameter. If you want to cover the 1000 meter, of course, you need more copper cross section, and when American wire gauge 16 or 18 is used, and depending on the robustness of the cable jacket and so on, cable could be around 8 millimeter already. So that's why it's not so easy to find. But also for this, we have an application note with some details. It was one of the first ones we created because it's very important to have compatible products between the cable in the market and the connectors itself. Good question also, yeah. But it depends a little bit.
correct, yeah.
It's always, yeah.
So let's pick only two more of the ones. The next one I'm going to ask you, Matthias, is T1s come with both power and data transfer together? So it's a question. Uh, I believe you've covered that, but we'll just cover it again. The question is T1s come with power and data transfer together.
Can you
If the,
repeat?
sure, I understand.
I have some background noise here. Sorry for.
So if the question is, do T1s come with both power and data transfer together?
Yeah, I mentioned this PUDO standard, so this power over data line. This standard is developed together with the different protocols, but it's completely independent from the different speed protocols. So it can be combined with all standards we have. And if you like, you can also use it without single pair Ethernet. So Poodle, at the moment, offering voltage level from 12 to 48 volt. And the maximum power you can transmit to your end device is 50 watts already. It's a lot for many sensors and small actuators, yeah.
All right. Well, we only have time for the last one, and Christoph is asking, does the cable need a shield?
Yeah, it's a good question. The car industry tried to work without shielded systems, but also at higher speeds, they identified they need shielding. For the industry with many harsh environments, so frequency transformers and a lot of EMC noise around, we propose to work always with shielded versions. And the connectors itself, if you have a look at it, are shielded, and also the cables we use. So for the industry, we strongly propose to go shielded. That makes the life much easier, and it's more secure also for the data transmission.
All right. Well, let's stop at that, and we pretty much passed the time that we had. Again, just a quick closing before the quick points here. Of course, thank you everyone for joining. I hope the session was helpful. It's going to be available on LinkedIn, on YouTube, and of course, if you need more information, I'll just pull up a slide momentarily where the LinkedIn link as well as the website link of the SPE will be there, so you could get a whole lot of information there. So before I hand it over to Matthias for his closing thoughts, just wanted to bring attention to the people who are here that at Utthunga we do a lot of such events to bring in thought leaders from the industry on topics very relevant to us, existing or upcoming technologies. And so just follow us on our LinkedIn page. Just search for Utthunga, Utthunga on the LinkedIn search bar, and follow us. A lot of exciting stuff keeps happening. In fact, there are two coming up in the next 4 weeks, a month. There's one on the 20th of next month, July, where Frank Moritz from SICK AG is going to be talking on another very relevant topic about the role of IO-Link, the protocol IO-Link, the role of IO-Link. So that'll be an interesting one. Then there's another one 2 weeks before that, which is 2 weeks from today, with the managing director of the FDT Consortium, Mr. Steve, around the topic of migration to FDT 2.0, which is a new enhancement to the FDT technology for field device integration. So yeah, Matthias, over to you for your closing thoughts on this topic.
Yeah, thanks a lot for your time today, and I hope you got some useful information. The time is very limited. You can reach us later on also on LinkedIn or at the websites from our members or from the partner network website. Yeah, and we are also happy if you are interested in this technology, wants to work with us. So also invitation for everyone who wants to join our powerful international network, then we can work together to bring SPE successful to the market. And I'm very happy also to serve for the Industrial Partner Network as a technical leader of our group. And thanks a lot for joining here. And this is a communication technology, and I hope it brings the industries, the devices together, and also the people. And thanks a lot. And I hope we see us next time in one of our webinars or also in the face-to-face events. Yeah.
Great. Well, great. Thank you so much, Matthias, for spending the time to share your views and thoughts about the technology, about what's going on and what's to be coming. Thank you so much to you once again, and thank you, everyone. So wherever you are, a time of the day, good evening, or a good start to your day. Thank you very much.
Have a good time.
All right. Bye-bye.
Bye-bye.